We are going to be talking about proving identities and these problems that you have on the front part here. Most of these are from section 3.1 or similar to the problems from section 3.1. Some of these problems are from section 3.2 and some of them are from section 3.3. So some of that stuff that we skipped in chapter 3 is coming back into play here. So first of all, be sure that you're on the right side. We're not doing the homework side. We're doing this side right here in class. It's got 14 questions on it. These are just some helpful hints on working through proving identities, and you can use this to help you with your homework. You're not going to be using this on your test, though. And I think I've mentioned this before, is that the reason why we skipped this in the homework is because these problems really should be worked out paper and pencil type problem. You don't, in my opinion, you don't really learn how to do identities, proving identities by having a drop-down menu and multiple choice questions in my math lab. It's like asking you to write a business letter using drop-down menus without ever you asked to write a business letter. Well, that doesn't make sense. So we're doing this by hand. So your homework, paper and pencil homework, you're going to turn it in to me and I will grade it using a rating pen like we did back in the olden days. All right, so problem number 1 here. And I'm going to write down this problem in red marker here. Okay, that's what I want to try to prove. My first step is going to be to write down the left-hand side of this. So I have sine x times cotangent x equals. Now, what I want to do is to make an equivalent statement over here by changing this somehow. And my handout here is going to give me some different strategies. Well, my favorite strategy is to change everything to sines and cosines. So I think I can probably do that. So this is going to equal sine x, a cotangent. And you could use your reference sheet if you need to. You're probably going to want to keep that reference sheet handy because it has your Pythagorean identities in there. So you can see cotangent is cosine over sine using your quotient identities. So this is cosine x over sine x. Well, now my cosines can cancel, right? Now I'm not going to put marks through it because I want to be sure that the teacher sees what I have written. If I put marks through it, then you can't see what I've written. So the sines cancel. So that just ends up with cosine. And that's what I'm trying to prove. That's what I want to end up with. So I've done it, right? I've got this left-hand side is equal to this right-hand side. Okay, problem 2. Tan x over cotangent x equals. Be sure that you're writing your proofs vertically. They don't go out horizontally. I'm going to start with what's on the left-hand side here. Now, technically, you could start with either side. You don't normally want to start with the more complicated side and simplify it or change it around to make it look like the other side. But I think on all of the problems that we are given, the left side is the more complicated side. So that's where we're going to start. I can do this problem a couple of different ways. I could change everything to sines and cosines, but I could also use my reciprocal identities. You know what I think I'm going to do is I'm going to rewrite this as tangent times 1 over cotangent, because I know that 1 over cotangent is tangent using my reciprocal identities. So now I can say that that's tangent. So I have tan x times tan x. Well, that's tan squared x. So I have everything written out step by step. It's all neat. It's vertical. You need to be sure that you know how to organize your work correctly and show every step along the way with this. Okay, anytime you have squareds, you need to either be thinking Pythagorean theorem or factoring. If you look through your reference sheet, you've got squareds here in your Pythagorean identities, and you've got squareds over here as well. But Pythagorean identities is what you're usually going to be using this as. So start off with writing down the left-hand side here. And just a reminder, be sure that your squared goes before the x. It doesn't go after the x. And I can, like I said, I can do this problem a couple of different ways. You have to be sure that you know where you want to end up. I want to end up with just cosines. So I would like to get rid of this sine squared. Well, I know that I can rearrange this Pythagorean identity to solve for sine squared. It would be 1 minus cosine squared. Okay. So I've got this cosine squared x, and then I'm going to subtract parentheses 1 minus cosine squared x. Okay, so I just, excuse me, rearranged this Pythagorean identity to solve for sine squared, and I replaced sine squared with this. Now this is all in parentheses. So I need to drop the parentheses and distribute this negative. So that's going to give me cosine squared x minus 1 plus cosine squared x. Now I can add my like terms. Cosine squared and cosine squared is 2 cosine squared x and then minus 1. And that's what I was trying to prove. Secant squared x over tan x equals cotan x plus tan x. Right? That's what I'm trying to prove. And if you're unsure where to start with these problems, one thing that you can do is look at your number of terms. I already gave you a hint on like starting with the x squareds to use a Pythagorean identity, but notice that you have one term here and you have 2 terms here. Remember, terms are things that are numbers and variables that are being multiplied or divided. Terms are separated by addition and subtraction symbols. So I'm going from one term to 2 different terms. You know, your reciprocal identities and quotient identities don't do that, but the Pythagorean identities do that. You can go from 2 terms to 1 term here using that. And, you know, here your double angle formula can get you from two terms to one or two different tangent functions, but it's still just one term. So I'm going to try to use a Pythagorean identity here. I'm going to start off by writing down the problem that I'm given on the left-hand side. And then I want to do something to change that. So I'm going to look at this secant squared. I know secant squared is tan squared plus 1. Okay. So I'm going to write my numerator as tan squared x plus 1, and my denominator is tangent of x. Okay. Well, this is sort of on the right track. I've got an addition sign in there. What I can do next is to split that fraction up. And let me explain what I'm doing there. Now, normally, if you have a fraction, say 2/17 and 3/17, we would add that together and get 5/17. And we normally skip this part right here. You just add those two fractions, you get 5. Right? What I'm doing is starting here and going backwards. I'm just taking this and splitting this up into two different fractions. So I have tan squared x over tan x plus 1 over tan x. So one of these tangents is going to cancel. This would just give me tangent of x. Well, that's sort of what I want up here. Well, 1 over tan is cotangent, right? That's my reciprocal identity here. So this is plus cotangent. That's almost like what I want. The only thing that's different is that's not in the right order. So I can switch those two around. And now I have what I'm supposed to. Okay. My next problem that I want to do here, I have sine x times sine x plus cosine squared x cosecant x equals 1. Well, hopefully you'll know that, because of that equals 1, you're probably going to use the Pythagorean theorem or Pythagorean identity in there somewhere. With this problem, you may be tempted to try to start off by replacing this with 1 minus sine squared, but I think what I did, I distributed the sine x. I multiplied this. So I start off with what's given to me. I'm going to distribute. So I'm going to have sine squared x plus sine x cosine squared x secant x. I'm going to try and simplify this last part over here because I know that cosecant is 1 over sine. So I'm going to write that cosecant as 1 over sine, and I'm going to put it in the middle here, just so it's easier to see that these are going to cancel out. And this is going to give me sine squared x plus cosine squared x. Now, if you wanted to say that this cancels out to 1 and then 1 times cosine squared, and then in the next step put cosine squared, that's fine, but we could just cancel out here. And sine squared plus cosine squared is 1. That's Pythagorean identity there. Any questions on that so far? Okay, problem 6. Cosine x plus cosine x tan squared x equals secant x. Again, you're going from 2 different terms to 1 term. So we're going to be using the Pythagorean identity in here somewhere, probably. And you may say, okay, I want to replace tan squared with secant squared minus 1, and you can do that. But what I'm going to do is to factor a cosine out of these 2 terms. So starting off by writing down what I'm given. Factor out a cosine. So I have 1 plus tangent squared x. So now I can use the Pythagorean identity because I know 1 plus tan squared is secant squared. So this is going to be cosine x times, what did I say, secant squared x, secant squared x. And I can simplify that because I know that secant is 1 over cosine. So I'm going to write this secant squared as secant times secant. And then I'm going to replace this secant as 1 over cosine. Now I could have replaced cosine as 1 over secant. It doesn't matter. There's more than one way to do this problem. So this cancels out and I'm left with secant x, which is what I was supposed to be left with, secant x. Any questions with that problem? I want y'all to try to do problem 7 on your own. This problem 7 should be very similar to problem 6. Okay, I said that I'm going to factor out secant from both terms. So factor out secant x, so I have 1 minus sine squared x. Well, I can use the Pythagorean identity here. And I get cosine squared x. I'm going to write cosine squared as cosine times cosine. And I'm going to write secant as 1 over cosine. Okay. This is 1 over cosine. And this is cosine times cosine. Well, now I can see that these 2 are going to cancel, and that just leaves me with cosine x. Any questions with that? Okay, the next problem is going to take up a little bit more space. I'm going to change papers here. I've got 2 fractions that I'm adding together. I've got 2 terms here, right? Sine x over cosine x plus cosine x over sine x. And I've got that equal to secant times cosecant. Well, there doesn't seem to be anything that's obvious. I mean, I could put sine over cosine as tangent, tangent, cotangent. That didn't really help me much. So we're just going to add fractions. You know, get a common denominator and add the fractions. So I'm going to start off with the left-hand side written just like it is. And for those of you who took intermediate algebra here at SAU, that you remember, hopefully learning how to add and subtract rational expressions, how to get my common denominator. A common denominator is going to be sine times cosine. So I need to multiply this fraction, top and bottom, by sine. I need to multiply this fraction, top and bottom, by cosine. So I have sine x over cosine to start with. So I'm going to multiply top and bottom by sine x. Over here on this fraction, I start off with cosine over sine. So I need to multiply top and bottom by cosine. If y'all don't remember how to do that from intermediate algebra, you can go back and look at, I think I have a YouTube video on that. I may not, but if you have questions on how to find a common denominator to add fractions, let me know and I will help you with that. All right, I'm going to just clean this up a little bit. I'm going to write this as sine squared x. The numerator here I'm going to write as cosine squared x. And my denominators both have sine cosine in them. I just want them to be both in the same order. So I'm going to put, doesn't really matter. Let's stick with cosine first, just because that's what it is here. Now I have two fractions with common denominators, so I can add these two together. So I have sine squared x plus cosine squared x over cosine x sine x. And this is a Pythagorean identity. Sine squared plus cosine squared is 1. So I have 1 over cosine x sine x. So it looks like I'm on the right track here because I've gotten rid of my addition signs. I just have multiplication. I want my answer to be secant times cosecant. I know secant's 1 over cosine. This is 1 over sine. So if I took this fraction and split it up, 1 over cosine times 1 over sine, then that will give me secant and times cosecant, which is what I was looking for. So you see I've added my two fractions there. We can also separate fractions out. On problem number 9, that's what I'm going to do. So again, start with what's given to you on the left-hand side. And I'm going to write this as 1 over sine x plus cosine x over sine x. 1 over sine is cosecant. And this is tangent. That's what you're asked to find. So that's pretty straightforward. Now, some of these problems get a little bit longer as you work through them, but you're still going to be using these strategies about multiplying or factoring, adding fractions, separating out fractions, using reciprocals identity, changing everything to sine and cosine, especially using Pythagorean identities. That's going to show up quite a bit.